everyone, and welcome back to twitch.tv/AWS. I'm Abby. I'm on the containers team here at AWS. I'm joined by Nick, who is a product manager on AWS App Mesh, and with Pontus, who is chief evangelist at VMware. Welcome, guys.
Thank you.
Thank you.
So this morning, we announced the general availability of AWS App Mesh. Nick, can you start us off and tell us a little bit what App Mesh is?
Sure. So App Mesh is application-level networking at AWS. So it enables you to run services on a variety of compute primitives like ECS or Fargate or EKS, and control the communication and observability across those services, independent of the specific languages or compute platforms that those services are using.
For those of you that are maybe a little bit new to this, can you give us the 10-second rundown of what a service mesh is?
Sure. So a service mesh is an application-level network that allows you to have different services. Say in a microservice architecture, you might have service A, service B, and service C, and you want those services to be able to talk to each other and get things like logs and metrics from those services without having to go inject a whole bunch of code into the services themselves. And so the mesh provides that functionality for you outside of the services.
So I know that App Mesh has been in preview, but I hear that, Pontus, you guys built something called Wavefront. Can you tell us a little bit about what you're building?
Yeah, sure. I mean, Wavefront is a platform that's been around for a while, right? It's basically born out of Google, and it's a massively scalable metrics platform and time series data platform, right? It runs on AWS, obviously, right? We have customers that use up to they actually ingest up to 5 million data points per second, right? So it's extremely massively scalable, right? And that solves a problem in the App Mesh and microservices world. Because when everything is distributed and you have hundreds, maybe thousands of microservices, you're going to generate tons and tons of data and you need to correlate that data. So that's basically what we do, and that's basically our kind of play in the App Mesh space. We do a lot of other things, right? We can basically take data from almost anything, and that's kind of the cool thing, that we can correlate App Mesh data, maybe data that comes from security cameras or whatever, right?
I heard a rumor that you have a demo.
I do.
Can you show us the demo?
I can, of course. So here we go, right? I mean, this is basically just basic App Mesh information, right? So we're getting our HTTP stats, we're getting things like that, right? What we can also do, which I will show you, is we can do distributed tracing. So we can look at the interactions between your microservices. But right now, we're just looking at this, and we see that spike here. Of course, I can zoom in on that spike, which is a spike in traffic, right? And of course I can sync that to all the other graphs. I can kind of try to understand what's going on here. This happens to be my security camera app. And so for some reason there's a spike coming in. So I'm going to go look at my security camera data that's captured from way outside of AWS. The security cameras themselves are reporting this back, right? Okay, let's have a look at that. Oh no, right? Not good. Because that's what the security camera data it looks like, because it's so many of them, right? And they're reporting data all the time. Yeah. So basically here's what we do that is kind of unique in our solution, is that we can correlate things, right? So what I'm doing in this case here is I'm saying, okay, I know that I have this specific shape of data that comes in. That's that spike we looked at before, right? Now, out of that mess of data, I want to correlate anything that kind of has the same kind of shape, has the same kind of behavior as that, and that turns out to be this. So now I reduce that mess down to a bunch of candidates of what's really going on here. And I can see that, well, during that spike, it's actually 10 specific security cameras that are going haywire and sending a bunch of data, right? So that's kind of the what Wavefront gives you above and beyond just like App Mesh, right? Of course, we have all the other things, right? We can do things like, where am I here, right? We can trace transactions. We can see which transaction is the slowest. It happens to be that one, right? I can go in and I can see, oh, that particular microservice that handles that, or sorry, that particular transaction, it has a bunch of spikes here in performance. Let's have a look at one of them, right? And I can say, oh, order shirts here. Okay, let's have a look at that one in particular. And it turns out here that why is that performing badly? Well, it's the happens to be the styling and packaging microservice in my t-shirt shop in this case, right? So that's another thing that we can do, obviously, right? We can do distributed tracing. And the uniqueness here is that we can mesh that all together, or mash that all together, is probably the right word. We can mash that all together with data that comes from other sources, data that comes from your infrastructure, data that comes from AWS itself. And we can answer questions like we just did with those cameras.
So what happens if you add a new security camera? How do I get new cameras that I add or new compute resources to join the mesh?
Well, assuming that the cameras already know how to send data in, that's kind of a no-op, right? Or not a no-op, but it's a no-brainer, right? So what you do is you basically have an API token and an address you're sending the data to, and that would just magically show up. We have agents and data collectors for a couple of 100 different technologies, right?
I feel like what's cool, right, is that it doesn't matter what kind of resources it is. To the mesh, it's all kind of the same.
Exactly, right? We like to say that our data model is kind of flat, right? So you don't need to know all the relationships. Oh, this one talks to that one talks to that. You can just look at that flat data and say, okay, I need to correlate all of this. I need to find this needle in a haystack somewhere.
And correct me if I'm wrong, but things don't talk to each other by default. So in the mesh, they cannot talk to each other, and I opt them into talking to each other rather than opting out.
You can actually do both ways, but yes, by default, you configure your mesh and you explicitly list the dependencies between your services, so which services are allowed to talk to which other services in the mesh. That's correct.
Cool. So what do you, I know that you had as like a couple of the outcomes for it, but what do you think are some good use cases where people might want to use something like this kind of beyond security cameras?
Well, I mean, in almost any application you have out there, you have an unexpected behavior. It's running slow, or you get a spike in usage, or something like that, right? And it doesn't matter if it's security cameras or if it's like a million cell phones hitting your app or something like that, right? There's always that use case, that needle in the haystack kind of use case. We've used it for identifying bad switches in networks. Same thing there, right? You got 1,000 switches in your data center, and there's this one that misbehaves, and it's hard to know that just by manually looking at it.
Right.
So you can correlate data. There's a ton of use cases, and in fact, I think there's going to be a URL. There's a trial you can sign up for Wavefront, and it has like all of those examples with live data that you can play around with.
So if you're following along on Twitch chat, we'll grab a link for you for the Wavefront trial so that you can hang out and look through some of your examples yourself. I guess my question is, what happens next? So where are you guys kind of thinking about? Where do you go from here? What kind of features do you want to think about? What's the direction that Wavefront's going?
So our direction is clearly like towards focusing on containers and microservices. We have a bunch of other technologies that are similar to App Mesh, that are similar to these types of technologies. We're actually going to launch one of our own at some point here. So we're really moving into the microservices and container space, right? Because here's the thing, microservices are wonderful because it gives you that, you can kind of distribute the work and everybody's concerned about their own thing. That's great, but it does add complexity. You're going to have such a big set of services that no one person actually can understand all of them. That's where you need technologies like this that can correlate.
And it gives me the big picture, so I don't have to, instead of having to look into every individual resource, I can look at everything at the mesh level and say, okay, well, this is how these things talk to each other.
Exactly.
Here's where the spike came from.
Exactly.
Nick, any questions?
So I think it's really exciting to see a partner developing this kind of solution. I'm curious about when it comes to logging. So I view observability as kind of logging metrics and tracing. Yeah. I mean, do you view logging as part of that observability story as well?
So today, Wavefront is a time series solution, which means that we look at numbers, numbers on the y-axis, time on the x-axis, right? But we have agents and collectors that can convert log data into time series. For example, there might be things you can scrape out of the log, or you may want to count how many times something occurs in the log.
Yes.
And actually, that's kind of a big use case for us. We have a lot of customers that do that.
Yeah, that makes sense. And in fact, I've heard it often said that you can view metrics and logs as really part of the same thing, right? And metrics are a specialized form of logs, essentially.
Absolutely, right? So in terms of directions we're moving, I think we're moving in that direction as well. Right?
Yeah, right, that makes sense.
Okay, we are just about out of time with Pontus. Pontus, thank you so much for hanging out with us. We will be switching in just a second, and we will be joined by our friends from Weaveworks. So stay tuned. We're not going anywhere. Pontus, thanks for joining us.
Thank you. It was a pleasure. Thanks.
Yeah, thank you for coming on.
Thank you.
Hi, everyone, and welcome back. We are live now on twitch.tv/AWS. I'm Abby Fuller. I'm on the containers team here. I'm joined by Nick, who's a product manager for AWS App Mesh. And I'm also joined by Timau and Craig from Weaveworks, who are here to do an awesome demo for us. Guys, thanks for joining.
Yeah, thanks for inviting us.
So first of all, can you tell me a little bit about Weaveworks and then what you're here to talk about?
Absolutely. So we work for a company called Weaveworks. We are a startup in the Kubernetes space, and we have offices in San Francisco, London, and Berlin, a distributed team, and we've been running Kubernetes production for up to 4 years now. So our founders actually came from the background of creating RabbitMQ, if anybody knows that, and now we offer products that help you monitor and manage your Kubernetes clusters. We're working on a Kubernetes deployment, and because of those 4 years of experience, we actually offer consulting, training, and support for anybody who'd like to get started with Kubernetes.
Fun.
Yes. And do you want me to go right into the App Mesh?
Yeah, tell us what you got.
All right, so we're really excited about the App Mesh GA, and we've been working together, so we feel like basically the business values, right? So if you're excited about AWS App Mesh, you would want to leverage it and maximize it and do things like A/B testing and canary deployments so that you know that you can roll out new versions of your app and not be worried that something's going to go terribly wrong and have bad experience for your users and for your team. Not only that, wouldn't it be better if that was also automated in a certain way using powerful metrics? And even better, wouldn't it be great if it removes some of the complications of the App Mesh experience that could be potentially manual? So that's what we're promising today with a project called Weaveflagger, together with some of our open source projects, or the possibility of using it with our commercial product called Weave Cloud.
Gotcha. So I know Flagger is open source because
Yes.
James was floating around the link on Twitter a couple minutes ago.
Yes, and it was created by Stefan Prodden on our DX team. I have to definitely call him out. Did great work on this. Yes.
We'll see if we can throw some Twitter handles in the Twitch chat.
Yes.
So what is the experience from Flagger that an App Mesh user can try today?
Yeah, absolutely. So I gave some links to you guys, so hopefully you could check them out. There are install docs as well as a tutorial on how to do canary deployments. And basically the idea is all the things that I mentioned. If you're using App Mesh today, you can go and play around with Flagger, and that will help you to do canary deployments, which means that if you're going from version 1 to version 2, a new version, instead of just changing from, I'll be showing you an app from blue to green instead of just going straight to green and then having everything go wrong. You can dole out based on very smart metrics until you reach a point that okay, none of our error thresholds are met and we can safely move to the new version, move traffic to the new version. And as I mentioned, Flagger is really great that it automates that process. If anybody knows Prometheus, it's an open source monitoring software that's part of the CNCF. Very advanced metrics, so it uses those metrics to make those decisions. And then, as I mentioned, it will abstract out some of the complexity of App Mesh by creating some necessary App Mesh objects and also making sure that they're synced so you don't have to do that manually. So.
Did you guys have a demo that you wanted
yes.
to show us?
Usually I hear you say, I heard a rumor.
I do. I've been trying to switch it up because people complain that I always did the same thing, but this is what I get.
Starting things with rumors. Yeah,
it's me. I'm starting all the rumors.
Exactly. If you want to switch over to our screen, are we?
They will. It's already up.
It's already up. Excellent.
Let's roll.
So I can show here that we have a sample app that will go from blue to green. So as I mentioned, you don't want to just send all your traffic to the green version and find out everything goes wrong. So instead, you'd want to dole out the rerouting. So as I mentioned, this is open source. You have to make some open source installs to make it work. We are using the Weavecloud UI here that we sampled. So if anybody wants this, tweet to us and we'll make it happen. So here in Weavecloud, we have this deployment capability, and here I'm going to choose our sample app. And here we have this canary release possibility. So as you can see, we're at 0.0, and we're going to upgrade to 0.1, which will be the green version. And here we have some thresholds that we set. So the 50% means that we'll be rerouting 5% of traffic in certain increments and testing as it goes. And if all goes well, then when it reaches 50%, then it says the rest of the promotion can go. And we have certain thresholds here that, if we have time, we could explain how they work in more specifics. So here we'll do a release, and this will take a little bit of time, so I can explain some of the things that goes on in the background. But what's important here is that what you'll see here is using these graphs, you'll see that right now all the weight, the traffic weight, goes to the existing app, which is blue, and the canary is currently at 0, which will be the green app. And over time, the primary will go down to 50, and if there are no errors, and in this case there won't be, then it'll go back up to 100, meaning that now 100% of traffic is going to the green app. And canary as well will go from 0 to 50 and back down. In Weavecloud, we also show some CPU and memory usage. So you'll see currently all the CPU and memory is going to the pods that support the blue app. And over time, you'll see less resources going to support those apps as new pods get spun up that need support to show the green app. So while we're doing that, if there aren't questions, I could explain a little bit of what's going on in the background.
I would love for that. I would love that.
I know, just Twitch is just like flooding with questions now.
Twitch is mostly concerned about the box that I'm standing on.
Yeah, exactly. I'm very concerned about the Tom Cruise box.
They know that I'm not this tall.
I know.
Whenever you're ready, I have a question for you.
Oh, you have a question. Okay, that's why we have questions. Yeah. What's your question?
So I'm wondering if you're doing the deployment of the pods independently from the routing of the traffic, or whether the routing is synchronized with the deployment of the pods, if that makes sense.
It's both.
Okay.
So you can connect Flagger to use a horizontal pod autoscaler, or you can just have it deploy a set number of replicas.
Right.
It'll start rolling out those replicas as it starts diverting traffic. So if you have like 4 pods in your normal deployment and you're not using horizontal pod autoscaling, it will deploy the 4 pods and then start routing traffic over to those pods. If it's successful, old pods are killed, new pods are primary. If it's not, new pods get deleted.
That's because that's one of the things that I think App Mesh and service meshes in general allow you to do, is to separate the logic of deploying the pods or the tasks from the logic of routing traffic to them.
That's exactly right. And that's what makes Flagger so powerful, is it's doing that. It's creating all of the necessary objects in the App Mesh layer without your intervention, just through some really easy configuration.
Wow.
So that's what makes Flagger so great in this, as a piece of this puzzle. Yeah.
Great, thank you.
Yeah.
It looks like
Do you want to go back to your...
Yeah. We actually can complete the demo because we've completed it. Oh no, it's actually still working. But you'll see that if you were sharing the screen, we've been kind of going between blue and green as traffic's been doled out. And now we're at the 50% point at which you'll see it's starting to complete, and you'll see that as I mentioned, the primary rate has hit 50%, the thresholds have been met, and actually it's really important to mention here that those thresholds are things that any company would set up, right? Like based on your SLAs, based on whatever requirements you have, so you have that control, and that's baked in into your setup so that it'll do what you want. So here we go, you can see that now all the weight has gone to the the green app, and you can see it now is 0.1, and the canary weight has now gone down to 0 because there's no more canary traffic. And as I mentioned earlier, when you look at the CPU and memory usage, you'll see here the pods just getting spun up here as the others are getting spun down, and these basically, the graph breaks off as the new ones get spun off. So it kind of helps to visualize what's going on in the background. Yeah.
Right.
Do you guys want us to go
Oh, I was looking at the graphs.
Yeah, yes, the graphs are mesmerizing. Yes.
I love a good graph.
Yes. So yeah, and so now you can see that we've moved to point 1. What's important here is that if you go to, I can explain a little bit sort of our GitOps methodology. So GitOps is operations by pull request, so you can leverage the power of Git to make sure that you can have a line of requests that are then gone through the right set of people to make sure that you make your changes according to a proper process. So here you can see, actually, is this an old one? I had gone from, maybe this is the wrong one. Let me go back. Okay, so you can see here now the diff. It's literally in the deployment YAML file, and it goes from point 0 to point 1.
The important thing here is that the state of the cluster is always in sync with what's head on Git. So Git and the cluster are a one-to-one mapping of configuration to what's actually happening in reality.
Yeah, and so what's important here is it's just an image that I took from the GitHub page, is that that file that we were looking at was a deployment YAML file, and that's where the diff happens. Basically, with the GitOps methodology, you want to make sure that those manifest files are in that repo. And in this case, either if you're using Weave Cloud or if you're using open source Weaveflux, the job is to make sure that those files are synced with the cluster. In this case, we made a change through Weave Cloud, or you can do it through Git push. You'll make a change to the deployment file that triggers Flux to do its job, and then in this case, it triggers Flagger to say, oh, you want to make a change, but let's do it in a canary deployment style. So
Awesome.
It's kind of an easy way to.
Unfortunately, it looks like we are just about out of time, or over time. I'm not sure which one.
I see the red light blinking for a while,
Yeah.
so.
The clock is very confusing.
So we are going to wrap up here with Weave. Guys, thanks for joining us.
Yeah,
thank you so much for
We'll
having
be
us.
right
Yeah.
back in a couple of minutes here on twitch.tv/AWS.
Thank
We'll see you
you.
later.